This is a lovely arrangements question where we're interested in V numbers where the digits go high, low, high. So for example, I could have 7 and then 5, and then this has to be more than 5, so 8, for example. That would be a high, low, high number, so a V number. We want to know how many 3-digit V numbers there are. So it's all going to depend on the tens digit really, because there's going to be no V number where the tens digit is 9. There's going to be lots where it's 0. So I'm going to split it into those cases where I just write down the tens digit and see how many numbers I have for each of these cases. So when I have 0, I can have the digits 1 to 9 here. So there's going to be 9 options. And there's going to be 9 options for the units digit. And the product rule accounting says that we multiply these because for, say, 1, I've got 9 options for the units digit. For the hundreds digit being 2, I've got 9 options for the units digit, and so on. Because there's 9 options for the hundreds digit, I have 9 plus 9 plus 9 for each one, so 9 times 9 overall. I'm just going to write that as 9 squared for the moment. It is 81, but let's write it like that. Okay, if we move on to 1, then I can have the hundreds digit being any number from 2 to 9. So there's now going to be 8 options there and 8 options here. I'm going to get 8 squared, and we see a pattern very quickly forming. So for 2, there's going to be 7 options because it's all the numbers from 3 to 9. And I'm going to times them together, give 7 squared. So I'm going to get 9 squared when it's 0. I'm going to add the number of options when it's 1. That's going to be 8 squared. Then 7 squared, 6 squared, 5 squared. Let me just fill it in as I go. That's when I've got 2 as the tens digit, 3 and 4. Then 4 squared plus 3 squared plus 2 squared. That's going to be when I have a 5. This is when I have a 6 because I could have 7, 8 or 9. Then this is for 7 because I can have 8 or 9. And then finally we've just got a 1 squared when I have an 8 there because the only option would be 989. So that is going to be our answer. We just now need to calculate this. So we'll do it the long way first of all, and I'll show you there is a quick way, in fact, but it's unlikely you would have encountered this before. Okay, so 81 plus 64 and so on. It really helps to know your square numbers here. Right, and let's think about how we can do this efficiently. Rather than adding them all up in a big line or adding them one at a time, is there a quicker way? Well, 64 and 36 quite nicely add to give 100, so I'm just going to keep a running total there. 49 and 1 add to give 50. 16 and 9 add to give 25. So if I add another 25, I've got another 50. And that just leaves me with 81 plus 4, which is 85. Okay, that was quite good. So I get 285. That is going to be my answer. I'm just going to share with you the quicker way. In some of my videos, I talk about how you can add up the numbers from 1 to n really quickly. And I would highly recommend learning this, a half n times n plus 1. Turns out there is a formula for squares as well. It's a little bit more complicated. It's taken me a bit of time to remember it, but it's a sixth times n plus 1 times 2n plus 1. It's not going to save a great deal of time here, but if you're adding even more, then the more you're adding, the better this method becomes. So for us, where n is equal to 9, because that is our last square number, it's going to be 1/6 times 9 times 10 times 19. And then I might just divide, rather than times them all together, I'm going to actually divide the 9 by partly by the 6 to give me a 2 here and a 3 here. And then I think I will divide, yeah, let's divide the 2 by the 10 by the 2 rather, to give 5. So it's going to be 15 times 190. So that's going to be 190 for the 10 times 190 plus 95, which also gives 285. So it doesn't save a lot of time here. Not Not really, but a little bit. Um, it's just an alternative. It's good to see it, and you might want to investigate it and learn a bit more about where it comes from. Anyway, well done on these numbers.